Good afternoon, guys. Today we are going to do the VHDL program for half subtractor and full subtractor. Okay. So half subtractor, we have how many inputs and how many outputs, and for full subtractor, how many input and how many output we have. Yes, we will see. So let us share the screen with you. Okay. So here half subtractor x. Here you have x and y as the input. Half subtractor x and y is your input 0, 0, 0, 1, 1, 0, and 1, 1. Difference here it is 0. Difference between these two is 0. Difference here it is 1. Difference here it is 1. Difference here it is 0. And the borrow here it is 0. The borrow is 1 here because 0, 0, 1. Borrow is 1 here. So we will borrow 1 here. And here it is 0. Okay. 1 minus 0 is, so we don't borrow here. Here the borrow is also 0. So when we write the Boolean expression, it is a. So how we can write the Boolean expression here? So we can write this x bar y plus y bar. So it is x of y. Okay, and here it is. So here it is only 1 here. So it will be x bar y. So this is the Boolean expression for the difference, and D is stand for difference and B stands for borrow. And the full subtractor, when we go to the full subtractor here, let me open. We have 3 inputs here and 2 outputs. So let us write the table 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So difference here it is 0. Okay, and borrow is also 0. So difference here between these two is 0, and different between these two is 1. Okay, first we will compare these two. Okay, and result with this. Okay, here it is 0, and 0, 1 is 1. So it is 1 here, and the borrow is, and the borrow between these two is 1. Okay, similarly it is 0, 0 is 0, 1 is difference is 1 here. The borrow is 1 here, and the difference between these two 1. Again the borrow is 0. So this means we will check all together. So 0, 1 it is 0. The borrow is 1, and the difference is also 1. Here the difference is 0, and the borrow is 1 here. Here the difference is 1, and the borrow is 0. Here the difference is 0, and borrow is also 0. Okay. Similarly, we will do for the all. Like here it is 1, 1, 0. So here the difference is 0, and borrow is also 0. And between these two, when we compare these two, it is the difference is 0. Okay, 0, 1. The borrow is 1, and the difference is also 1. So here we will complete the two table for full subtractor. Okay, difference is D equals to x XOR y and XOR z. When we solve this expression, you will get x XOR y XOR z, and borrow is x bar y plus x bar z plus yz. You can just write it as a x bar common yz. Okay, you can just write it like this also. X bar as a common, b is equals to, let me write b is equals to x bar, you take it a common, and y plus z plus yz. Okay, this is the expression for borrow. So we will implement this in the VHDL. So So this is the VHDL programming, Xilinx ISC design suite. So here we will just create the new source. The new source here is new source file, new, okay. The project demo one is already created, okay. Just we'll write the new source VHDL module. Let us write H half subtractor, okay. Half subtractor. Let me write full. Let me write full underscore subtractor. So next VHDL module. So what are the inputs? We will see here. What are the inputs and output here? So inputs are X and Y, and D and B is the output. So input is X comma Y, and output is difference comma borrow. Okay. So this is our case insensitive. Okay, you can use any case here. So next finish. So here we create our general programming visual program. Okay, begin. So what you have here, input as D. Okay, you go to this. D is X or Y. Okay, X or Y, and borrow is not of X and Y. Okay, so let us write as Y implies difference D implies equals X XOR B. Sorry, Y. We are habituated of writing A and B as input. Okay, so no problem. Difference and borrow is output, B is borrow out, semicolon, not of X. So we will write not in the braces, not of X and Y, semicolon. Okay, so this is, here we have written the equation, Boolean expression, and the architecture body. In the architecture body we have written the Boolean expression, difference in the borrow. Okay, let us save. So it is saved successfully. So after saving successfully, we will go to the implementation part, and half subtractor is here. Okay, we'll make it as a top module. Okay, let us make it as a top module. View Rtl schematic. Let us see the schematic here. So the schematic is it's running Rtl schematic. At clear schematic. Okay, this is half subtractor. Okay, so let us make it as a full view. This is XOR. Okay, so this is AND operation and this is XOR operation. Okay, this is AND operation and XOR operation, and one vowel is there. Okay, so that means A so I not. So that means A bar X bar Y. Okay, X bar Y with the AND. This is the borrowed. Okay, you can see borrow here. Okay, B. You can see B here, and the D difference AX XOR Y. This is the schematic. Okay, so we can see this schematic and add clear schematic. So this is the truth table for borrow. Okay, and this is the truth table for difference. Okay, so AX or B. So simultaneously you can write the truth table also. Then we'll go for the simulation part. Half subtractor, schematic check, behavior schematic check. Okay, it is done. Simulate behavior module. So let us simulate it. So the window, simulator window will be open here. Okay. So what are the inputs you have? X, Y, D, and B. Again, I'm telling you, we can give this as a test bench also. So, but it is like just writing again new code. So no need for writing. Just you can give the force constant from the keyboard. So it is like we will give whole table here 0 force constant. So with the implementation part, we already proved it. Okay, with the simulation now we will prove. So it is 0 0 is 0 0. Okay. Y is force constant. Output is 1. Okay. So for 0 1 it is 1 1. Okay. Difference is 1 and the borrow is 1. Force constant difference 1. Sorry, x 1 and force constant output input 1 0. It is output is difference 1 and borrow is 0. So last force constant it is 1. For 1 1 the force output is 0 and 0. So if you want to view complete view, you can see here 0 0 is 0 0, 0 1 is 1 1, 1 0 is 1 0, and 1 1 is 0 0. Okay, because both are same, so the no difference and no borrow. So you can take down this. This is the half subtractor. Okay, let's go for the full subtractor here. So when you go to the full subtractor, you have how many? Sorry. So how many inputs you have here? 3 inputs and 2 outputs. So x, y, z is the input, and d difference and the borrow is the output. So let us just go to the okay. So same thing. We'll add new source here. VHDL module full underscore subtractor. Okay, full subtractor. Next. So what are the inputs you have? X, comma, Y, comma, Z. Okay. And difference and the borrow is your output. It has the output finish. Okay. So here the program body is created. Okay. So in architecture we have to edit that's it. So what is the architecture? Here you can see the architecture. Difference is X, XOR Y, XOR Z. Okay, let us write this. X. So difference implies equals. So you can use it is case sensitive, not sensitive. Okay, you can use a case equal X XOR Y XOR Z. This is my difference, and the borrow implies equals. So you can see here X not of X. Okay, not of X is multiplying with Y or Z. Y or Z. Z rows and in bracket you can write Y and Z. Okay, this is my borrow output. So Y and Z, right? Y and Z. So let us implement this, save it. Okay, it is saved. We will go to the full subtractor, make it as a top module. Go to the implementation part and make it as a top module. Okay, let us implement then view Rtl schematic. Let us use Rtl schematic here. Oh, there is some problem with the code. What are the error you have? Type of X. Okay, so not of X, Y or Z. Line 36. Okay, so we'll write this is all so in the bracket. Save now. Okay, save it. So where is the problem here? Okay. Y Oh, sorry. So here VHDL will not understand what exactly you are doing here. What we are doing here, not x, not x is multiplying. That means AND operation. It is doing AND operation with y or z. Let us save this. So it is now perfectly fine. So we'll view the RTL schematic here. So when you see the RTL schematic, so when in the technology schematic, you can verify your truth table. Okay, create a schematic, subtractor. So this is my XOR operation. Okay, the part is so map 111010001. This is 01001101. Okay, so here you can see what we have edited. We have just changed again. It is x XOR y or XOR z. Okay, and not of x, and this is x bar common, and we are multiplying with y or z and adding with y or z. Okay, so this is the same thing here. We have what we have written y and z. Okay, so let us go to the simulation part. Simulate behavior module, syntax. Okay, simulate behavior module. So force constant. You can see the simulation window. No, you cannot see application screen. Application. Okay. Force constant 0. Okay. Force constant 0. Apply. Okay. Force constant 0. Apply. Okay. For all 0, it is 0. Okay. 0 1 force. Oh, sorry. Force constant. Let's make it as 1. Okay. So it is 1 1. Okay. So previously we were getting 0 0. That was not correct. Okay. This is the correct thing. 0 1. Let us make y 1 and z as 0. 0 apply. Okay. So it is for 0. It is 1 1. Correct. Force constant. It is 1 again. So it will be 0 1. Okay. So let us make x as 1 now and y as 0 0. Z as 0. So it will be 0 0 1 0. Okay. The difference is 1 here. The power is 0. Y as sorry, z as 1. Okay. So 0 1. Y is force constant and z as 0. This is final. This is final. 1 1 1 1. Okay. So let us go table. It is 0 0 1 is 1 1. 0 1 0 is 1 1 and 0 0 0 1 1 is 0 1. Okay. 1 0 0 is 1 0. 1 0 is 1 0 0. Okay. 1 1 is 0 0. Last is 1 1 1 is 1 1. This is here full subtractor.